Okay, hello viewers, we are still looking at partial differentiation, and we've been given a question that p equal to sine xy. And if you look at this question, it's a typical example of function of a function, and so we are going to treat it as function of a function while we differentiate it partially. So for this question, we are asked to find the p, change in p, partial derivative of p with respect to x, and partial derivative of p with respect to partial derivative of y. So that is what we're asked to determine here. And so we are going to use function of a function, because this is sine and this is x, y. So this can be our a and this will be b. So a solution for our a, considering this question, we have p equal to sine xy. Okay, so let's make a mathematical statement and say let u equal to xy. We can call this equation 1. So we say from equation 1, let u equal to xy. So if u is equal to xy in equation 1, then p will be equal to sine u. What this means is, since we are now saying that u is equal to xy, p in equation 1 will be equal to sine u. And so we can call this equation 2, and we call this equation 3. And so the next thing we have to do is to differentiate partially u with respect to x. And so we say partial derivative of u with respect to partial derivative of x is going to give us y. I'm not going to do it the way I did the first question. I've done first question. So if you are differentiating u with respect to x, you are going to have, your answer will be y. Now of course there is a proof to this. So this is what happens. Because you are differentiating with respect to x, you keep y constant, and then you differentiate x because they are multiplied together. So you differentiate x, so this will be 1 times x raised to power 1 minus 1. So this will be 1 y dot 1 times x is x, 1 minus 1 is 0. So any number raised to power 0 is going to give you 1, so that we have y dot or y times 1, which is equal to y. So that's why we have it to be y here. Again, you can also say the partial derivative of u with respect to y. And so if you're differentiating u with respect to y in equation 2, you have x. It's just the same way here. Okay, we are not done. We also have to take the partial derivative of p with respect to u. So the partial derivative of p with respect to u will be, if you differentiate sine u, you're going to have cos u. Already you know that in your own differentiation, so it's not something that is difficult. And so since we've gotten to this point, since it is function of a function, we are going to be using chain rule to solve it. So for us to find the partial derivative of p with respect to x here, we are going to have partial derivative of p with respect to x will be equal to, we are going to consider this, okay, since we are dealing with x, we are going to say partial derivative of u over partial derivative of x times partial derivative of p over partial derivative of u. Of course, when you cancel out this, for instance, you're still going to be left with partial derivative of p with respect to x. And so when we've done that, we now slot in the values. So we have a partial derivative of p with respect to x will be equal to partial derivative of u over partial derivative of x is what? Okay, it's y times, this times, then partial derivative of p with respect to u is cos u. So this will give us equal to y cos u. But recall that, but y equal to, okay, sorry, but u we made a mathematical statement here that u equal to x, y, that u equal to x, y, so that u equal to x, y, so that finally our partial derivative of p with respect to x will be y cos u is xy, so we bring in the value. So with this we've been able to determine the partial derivative of p with respect to x. So let's also determine the partial derivative of p with respect to y. So question B is to determine partial derivative of p with respect to y. Of course we've taken these values already, so we are going to use this and this for the y. Okay, we are going to use this and this for the y. Note we are using du dy, okay, partial derivative of u with respect to y because we are dealing with y now. So partial derivative of p with respect to y will be partial derivative of u over partial derivative of y times partial derivative of p over partial derivative of u. So like I said, if you cancel out this, you are going to still have the same partial derivative of p with respect to y. So we are going to bring in the values. The partial derivative of u with respect to y is x, so it's here, it is here, and then times the partial derivative of p with respect to u is cos u. So we have cos u, and so this will give us x cos u, but u equal to xy, so that our partial derivative of p with respect to y will be equal to x cos, because u is xy, we now put xy here. So that will be the answer for partial derivative of p with respect to y, and this will be the answer of partial derivative of p with respect to x. So basically that is how to solve that question.